morning we have a session with three new interesting speakers, I'm sure of. And what we have done is to switch around the order so that we will actually start with Stewart Fast, who will talk on a geography-based critique of new U.S. biofuels regulation, which is related to some of the talks you listened to yesterday. So please, Stewart, take the floor.
Thank you, Anita. And good morning, everyone. Yeah, so this morning I'm going to offer a critique of the U.S. Biofuels regulation. It's a critique that's based on something that was alluded to yesterday, how you determine compliance with which corn ethanol meets this 20% greenhouse gas emission reduction threshold. And although I focus on the U.S. regulations, it's something that really, it's a fundamental challenge to any approach to kind of to meet or regulate towards a specific reduction threshold in any kind of regulatory approach. I write this paper with two co-authors, Mark Sonner, who's the Director of Society, Science, and Policy at the university here, and also Mike Berklisich at Carleton University in the Department of Geography. So, as we heard a little bit yesterday, the Renewable Fuel Standard 2, out of the Energy Independence and Security Act, Congress directed that fuels that should qualify under this new renewable fuel standard, corn ethanol, should meet a 20% emission reduction threshold. And then EPA was tasked with the responsibility to determine which fuels would meet that threshold and the way that regulatory compliance could be measured. And over a period of 2 or 3 years, they went through a number of studies and a couple of iterations and concluded that all corn ethanol basically produced in a new modern natural gas refinery will meet this emission reduction threshold. So our question going into this is, what's the ideal is that you have rulemaking based on solid evidence. So what is the evidence that is behind this rule and this regulatory approach? And if we go a little bit, so first of all, we have to dig a little bit into the life cycle assessment, or the approach that EPA did. So they were directed to look at the greenhouse gas life cycle emissions for biofuels throughout their life cycle, of course. Now, what you see on here on the right-hand side, this is taken from one of their regulatory impact analysis statements, is the different categories of activities and emission-generating activities that went into the assessment. And on the left-hand side, the large number of models and databases that were used to carry out this assessment. So some of these are economic models, fuel cycle models, greenhouse gas emission models. Now, so that's all fine and good. I mean, the EPA is very much saying that they're based on the best available science and an innovative approach to life cycle assessment. But when we drill down a little bit deeper, we think that there are two potential flaws or issues or features of this approach which are a challenge. The first is that there is a national kind of aggregate approach to some variables, but not others. Now, in particular, the corn farming emissions, so all the fertilizer, the fuel inputs, the energy to dry the grain, etc., all of that is collapsed into a single national aggregate value in the assessment, in the compliance, in the way that the compliance is measured. On the other hand, though, the other parts of the life cycle, in particular the ethanol refinery stage, turning the corn into ethanol, there's 34 different categories that are modeled, and that is given a much more subtle approach and becomes ultimately the basis for compliance. Now, the second issue is that in this approach, in this life cycle analysis that the EPA does, they use a relatively innovative or new way of doing life cycle assessment. Instead of, traditionally LCA is, you say you have 100 liters of ethanol being produced, that takes 250 kilograms of corn, which has a certain amount of nitrogen fertilizer associated with it, diesel associated with it, etc. All of those have emissions that go into, and then you calculate that up the chain to the final fuel product. Do the same for gasoline, and then you have your comparison. But what this consequential approach is to basically to try and determine the consequences of the policy. so the 2.6 billion gallons that are supposed to be incented because of the renewable fuel standard, and then model what that impact is in the wider system. So the secondary effects, not only of the 250 kilograms of corn that's being used to make the 100 liters of ethanol. That corn was at one point being used maybe for livestock, that's used on places that were growing soybeans or rice. So those all each have emissions, and using a marginal future assumption approach, you can try and determine what are the emissions associated with that wider system. So those are two features that we think lead to, it's based on a lot of assumptions, of course. This is from one of the draft regulatory impact analysis statements. And what I've tried to circle in here in the red boxes is that if you follow this logic and these assumptions through, you actually see some fairly odd results. And what I've circled here is the direct field and fuel inputs, the emissions from that, according to the policy, are actually going to decrease as a result of this new corn in the system to be provided for ethanol. So it's this weird logical extension of saying that, well, you're going to have a lot of corn being produced with not any more fuel or fertilizer input. So this is from the draft regulatory impact analysis, and it's the first proposed rule in RFS. It's subsequently been changed, but it just makes the point here that you can get some fairly odd results if you take these assumptions fairly. We can talk later. I see you're shaking your head there. But so what we decided to do in our paper here is to say, well, let's just put aside these projected emissions for a little while and look at some real world observed data. So we looked at Kim et al. Have published a study, a life cycle assessment, looking at corn and corn stover production in 8 different counties in the Corn Belt in the United States. What they document is a 3-fold difference in the greenhouse gas emissions that occur because of the production of those corn. So we just said, okay, what would happen if you then know that you have these location-specific differences in corn emissions, say that they're all going to be produced in this natural gas ethanol refinery, hold that constant and see how that affects whether or not the emission target can be reached. And this is from our paper, you see that if you use corn from each of those locations and then plug it into that kind of calculation, you see that only 2 of the locations will actually meet a 20% emission reduction target, and the others won't. So this is not, it's not totally surprising that, of course, some locations are going to meet the target and some aren't. This is not something that's relatively new or relatively hard to understand. But the idea behind this, of course, is that the reason for this is the quantities of field inputs and the emission generating activities are just so highly variable across locations, across geography, across space. And this has 2 implications, we think. Well, the first is that the EPA, because of this variability, is missing the opportunity to regulate on the basis of less greenhouse gas intensive corn farming. And secondly, if there's such a range in emissions across 8 different counties in the Corn Belt, what confidence can we have that the projections going forward to 2022 are going to be accurate and valid? Now, we decided to go a little bit further. So from the national level, which the EPA takes in this aggregate approach, to the sub-regional county level that Kim et al. Published in their work, and we looked at even further down, drilling down to the farm level, disaggregate to the farm level, and try and to see what effect that has on the data or the calculation. And when you do that, you see that not only the farms, of course, are individual systems, for lack of a better word. Some farms are going to be doing production activities that others don't. So the problem of this national aggregate approach to corn grain farming is that not only are the quantities of field inputs that range is obscured or masked, but it's also the frequency of the different activities that are masked. So again, this idea that you could regulate on the basis of activities that are less greenhouse gas intensive is being missed in this approach. So to sum it up, if you look at the greenhouse gas emissions projected to come from corn farming in the EPA approach, it's about 10 grams of carbon dioxide equivalents per energy unit. From the Kim et al. Data, it's much higher than that. You see the range goes a lot higher. And our own study from 2 different farms in Ontario is again higher than the EPA number, and the range is quite high. So, does this matter? Does this variability, this range matter? So the one way to kind of test that is to say, well, let's just hold the other emissions constant in this kind of sensitivity check. The additional emissions that have to be incorporated into that calculation from transport, from the biofuel refinery, keep those constant, and then how does that affect the final assessment? And what you see here is that obviously in the EPA assessment, 20% reductions are met, but if you look at real observed field data, it's less obvious that is going to be met. So our conclusion is basically that this idea of a 20% precise reduction threshold is not supportable. The geography of growing biomass is just too diverse. The inputs are too widely variable to be able to base that evidence, base that claim in solid evidence. And so I want to just finish off the last couple minutes here by presenting a few maybe ideas of why this might be happening in the approach. So I think remember that the turn to this particular environmental science method of life cycle assessment by the EPA is a response, a political response to this particular scientific criticism that we heard yesterday, Searchinger's et al. Paper in Science, and looking at the greenhouse gas impacts of land use change or potentially land use change as more corn is produced for the renewable fuel standard. So turning to this life cycle assessment method was a result of that, and they really do focus on the land use emission, international indirect land use emission problem through this method, but not so much in the corn farming variability. And also, I mean, from an administrative and regulatory point of view, it's no doubt going to be much more simpler to focus on the different categories that ethanol refineries say that all to come up with something that says, basically all corn ethanol produced in a certain type of refinery will qualify, instead of requiring either many refiners or many corn producers to do their own calculations and basically do their own kind of life cycle assessment. It becomes much more simpler and less offensive to the people that are in that chain. So, but we say that really, if you do want to have this idea that all the corn ethanol that's supported by the mandate is meeting a 20% reduction threshold, you have to disaggregate the data. And there are 2 ways that this can be done. You could do it by, as I just mentioned, by requiring individual producers to do their own kind of calculations. Or you could do it in a different way and say that, well, let's do a set of LCAs on a suite of representative farms on a regional or sub-regional level that all represent a different type of farming or a different grain farming system, and then do that on an annual basis. And then what you'll come up with probably is that corn from some regions under some farming techniques will not meet the target, but that's maybe the idea of the regulation to incent less greenhouse gas intensive corn farming and ultimately biofuels that meet a certain target. So I'm going to just leave it here with one final thought. I mean, I think the key message is this idea that you could get a single number, a 20% reduction threshold, or a single aggregate corn grain farming emission number is not really supportable. And this kind of cute or not so cute turn of phrase, is this evidence-based decision-making or decision-based evidence-making? And you see, if you look at this quote here from EPA in their response to comments, I think could be read in both ways. Basically, EPA was tasked with finding a way to say, well, what corn meets this 20% emission reduction threshold? And perhaps not surprisingly, they came up with a method which says basically most of the corn, virtually all the corn, is going to meet that target. That's it. Thank you.